and welcome to the final review warm-up number 5, all about systems of equations and inequalities. So as with the other ones, please go ahead and take a look at each of these, try it on your own, and then come back to the video to see how it went for you. So to solve a system of equations means to find the point or points that work in both equations. So for these ones, we are going to get answers that look like x comma y, because if you plug those in, it makes both equations true. So to solve by graphing, what we're going to do is we're going to graph each of these different lines and we're going to see where they intersect. So in order to graph it, we're going to take this first equation and we're going to get y by itself. So we get y equals 2x minus 1. So we're going to graph that because it's in slope-intercept form, which means we start down at -1 on our y-axis and we move up and to the right, up to right 1, or down to left 1. And then what we need to do is we need to take the other equation here, y equals 3, and graph that one. Now it is going to be a horizontal line because it is y equals, and it's going to go through -3 on our y-axis. So we're going to graph a horizontal line through -3 on our y-axis. And we're looking for the point that works in both of these lines. So we're going to go ahead and identify where they intersect. These graphs intersect at the point -1, -3. So this is our solution to the system of equations. You can always check your solution by plugging in -1 for x and -3 for y and seeing if you get 1 back out. So -2 plus 3 is 1, so it works in the bottom equation. And for the top equation, and for the bottom equation, if y is -3, then you get a true statement. Sometimes when you graph it, you might end up with parallel lines. That is going to be no solution. If you end up graphing one line and then the next line you graph is exactly the same line, that is going to be infinitely many solutions. We also can solve equations or systems of equations using substitution. So in order for substitution to work, you have to get a variable all by itself. So you see that y equals -2x plus 3. Once a variable is all by itself, you're going to take whatever it equals and you're going to plug that in to the other equation for whatever variable you solve for. So you get -3x minus, normally you'd write y, but instead of writing y, we're going to write whatever y equals. So the -2x plus 3. Then I would highly recommend when you plug this in, use parentheses, because you are now going to have to distribute any coefficient to whatever's in the parentheses. So you're going to get -3x, and then a negative times a negative becomes a positive 2x, and a negative times a positive becomes a -3 here. Once you have done that, now you can combine like terms and then continue to solve whatever equation you have for the variable. So we end up with this one getting x equals -10. Once you know what x is, what you can do is you can say, okay, now I need to find y. So you can go to either equation, it doesn't matter which one, and you can leave y alone, but plug in -10 for x and solve for y. So for this one, -2 times -10 is positive 20. So therefore, y equals 23. So our solution for number 2 is going to be a coordinate point, -10, comma, positive 23. And once again, always go back and check your answers to see if they're right. So you can do -3 times -10. And if you get positive 30 minus 23, you do get 7 back out. And the next one also, the 23 equals -2 times -10 plus 3. That also ends up working out. So you know that you have done it correctly. Let's go ahead now and graph a system of inequalities. So we're going to take one equation here, or one inequality, and we're going to graph it in slope-intercept form. So my y-intercept is 3 and my slope is -1/3. Once you get all of your points drawn, Don't just draw the line for this one because our inequality does not have the or equal to, which means it should be a dotted or a dashed line. For this inequality, we're going to test the point 0, 0 and say 0 is less than 3 when we plug in 0 for y and 0 for x. This is not true, which means 0, 0 is not part of the shaded solution, so it would be everything up above. You also can say y is greater than means that I'm going to shade above my y-intercept. For this next one here, we're going to go ahead and we're going to graph this, which means we need to put it in slope-intercept form. So in order to do so, I'm going to get y by itself, remembering to switch my symbol, my inequality, when I divide by a negative. So I get y is greater than or equal to 2x minus 6. So I go down to minus 6 on my y-axis and I graph that point and I graph my slope of positive 2. For this one, you should have a filled in or a solid line because your symbol here is or equal to. For your shading, I always go back to my original function or original inequality to make sure that I shade the right side. So I test 0, 0 by plugging it in for x and y. I get 0 is less than 12. This is a true statement, which means 0, 0 has to be part of the shaded side. So I'm going to shade that region over there. So when we get to this point, now we can't just leave our graph there. We have to identify our overall solution. And your solution here is going to be the overlap. So where do you see both purple and red shaded? That's where we want to finalize our answer. So our overall solution is going to be this upper part up here. And we again want to say that is our solution. So the last thing with this unit was elimination. So for elimination to work, you're going to pick either x or y, it doesn't matter which one, and you're going to try to make their coefficients be the same number, but one positive and one negative. So I'm going to choose x. So I'm going to go ahead and eliminate x by taking this top equation, and I'm going to multiply it by a negative 3. When I do that, my first term becomes a negative 15x. I get a negative 12y when I multiply that by negative 3. And I also have to multiply negative 30 by negative 3 to get a positive 90. I'm going to take my bottom equation here and multiply it by 5. So I'm going to get a positive 15x, a negative 45y, and a negative 90. And I chose a positive 5 because that would make my x coefficients a positive 15 and a negative 15. So that now, when I add my equations together, those undo each other. And so the x term is eliminated. And I'm left with negative 57y equals 0. So I go ahead and divide by negative 57. And I get y equals 0. Be careful with this one because y actually equals 0. It's not a no solution case here. Once you get y, you can go back to either one of your original equations and plug in whatever y value you got and solve for x. So when we do that, we get x equals negative 6. So our solution for this one would be negative 6, comma 0. Now, as a side note here, if you are ever solving and all of your x's and your y's cancel out, if you get a case that says 0 equals 0, that's infinitely many solutions. If you're using elimination and you get 0 equals some number and it's a not true statement, that's where you would write no solution. So thank you very much for listening. Hopefully this helped. Let me know if you have any questions.